Fatty liver, cancer, Alzheimer's, heart disease, these shouldn't have anything in common. They're completely different diseases. But what if they're not? What if they're the same underlying condition showing up in different places? I'm going to show you why, because if it is, it changes how we think about almost everything. So that's the proposition, that these are not separate diseases, but one underlying condition showing up in different places. If that's true, it suggests that we've been looking at chronic disease the wrong way. Across chronic disease, you consistently see evidence of an early preclinical pattern, a breakdown in how cells produce and use energy. And alongside that, you see the same cluster of signals: inflammation, insulin resistance, oxidative stress, different names, but the same signal. These are not independent problems. They're consequences of the same constraint: an energy-starved, fragile cell that, when it spreads across tissues, becomes what we label as chronic disease. So that's the claim, and it should be challenged. Take it to your doctor. Take it to a researcher. Take it to anyone working in this space, because if this is wrong, it should be easy to break. But if it's right, it resolves things that don't quite fit today. Why different diseases cluster together. Why treating one often improves the other. Why so many interventions overlap. And one observation that keeps showing up: there's one intervention that appears across almost every chronic disease: reducing sugar. Metabolic disease, cardiovascular disease, neurological conditions, that's not subtle. So then the question becomes, is that a coincidence? Or is sugar touching something upstream, something more fundamental that we've been focusing on? This is where fructose metabolism becomes critical to this conversation, not as the claim itself, but as a mechanism that fits the pattern. Because fructose metabolism does something very specific. It lowers cellular energy. When fructose is processed by fructokinase, ATP drops, uric acid rises, mitochondria shift away from high output energy. In other words, this pathway creates the exact state that the model predicts. And the results are predictable: a shift towards conservation, lower energy, increased hunger, fat storage, reduced output, not damage first, but suppression first. Now zoom out. If one cell runs in a low energy state, nothing dramatic happens. But if the pattern spreads, cells become fragile. Those tissues then become fragile. The system it supports then becomes fragile. And over time, that fragility expresses itself differently, depending on the tissue. In the liver, it looks like fatty liver. In blood vessels, it looks like hypertension. In the brain, it looks like cognitive decline. Different labels, but again, the same underlying constraint. Now, at this point, it's easy to say, well, we're eating too much sugar. But that's not the full picture, because fructose is not just something we consume. And that's where this might get a little uncomfortable. The body produces it. Glucose can be converted into fructose through the polyol pathway. And that pathway is triggered by high glucose, dehydration, salt, alcohol, hypoxia, stress. So then what looks like separate debates, carbs, alcohol, salt, stress, they're actually different inputs into the same system. Different triggers, one pathway. Then comes the critical clue: a condition called essential fructosuria. People born without a functioning fructokinase enzyme. They still consume fructose, but they don't metabolize it normally. They simply eliminate it in urine. And importantly, they do not develop the same chronic disease patterns, which tells us two things. This pathway is not required for survival. and it's directly tied to outcomes that we're trying to understand. Animal research reinforces this. If you block fructokinase in animals, many features of metabolic disease simply don't develop. Fat accumulation decreases, organ damage decreases, metabolic dysfunction improves, and this can happen even when glucose remains high in the diet, which suggests that much of what we associate with glucose may be mediated through fructose metabolism. This is now moving into human research. Pharmaceutical inhibition of fructokinase is showing reductions in liver fat, improvements in metabolic markers, and signals of organ recovery. So it's not just an idea anymore. It's becoming a validated target. At this point, the model becomes intuitive. This pathway is not a mistake. It's a survival system. When the environment signals instability, too much or too little, the body shifts towards conserving energy, storing fuel, and protecting itself. And it makes sense that multiple inputs would feed into it. It makes sense that it would influence taste and behavior. It makes sense that it would activate when opportunity appears. And in a world of scarcity, it would also be an advantage. In a world of constant exposure, that's when it becomes a chronic problem. So if this model is correct, then chronic disease is not a collection of separate problems. It's a different expression of the same underlying state, a persistent low-energy condition at the cellular level, amplified by a continuous activation of a survival pathway. Fructose metabolism may be one of the most reliable ways to create that state. And if that is true, then controlling this pathway becomes a priority, including with compounds like luteolin, a natural compound that directly inhibits fructose metabolism. So here's the challenge. Take this idea seriously enough to try to break it. Take it to your doctor, take it to a researcher, take it to someone you trust, and ask if sugar reduction moves nearly every chronic disease. Is that just a coincidence, or are we looking at a shared upstream mechanism? But you don't have to stop there. You can test this yourself. Remove the inputs that activate the pathway. Get rid of added sugars. Stabilize the environment. And if you want to go further, experiment with targeting the pathway directly, even with compounds like luteolin, which inhibit fructose metabolism. And then watch what starts to change. Your energy, your cravings, your stability. Because if this model is right, you shouldn't need years to see a signal. If it's wrong, you'll know. If it's right, you'll feel it. And it's a completely different way of understanding chronic disease.